Hey guys, it's Terry. So over the this past weekend, it was the last weekend I was going to have my Christmas lights up. Well, um, we were going to close it down Sunday, so into the first weekend after New Year's, and that's typically whenever we turn the lights off. Well, that afternoon at about 2 o'clock, there was a lightning strike about 2,000 feet from my house. And at least that's what it said on the lightning maps. It was very bright and very loud, and it took out. Um, it wound up taking out two power supplies and an unknown number of pixels out in the front yard. The thing that's not surprising that got struck and damaged the most is my fence. So I have like almost 2,000 pixels along the fence row, and yeah, only a section of maybe 300 are working that I've been able to verify. Hopefully, it didn't destroy too many once I get into it, but yeah, it was. That's not expected. It's 500 feet down that fence row, and you know, it has wires running the entire distance, of that thing. And so whenever you have long wires like that and a lightning strike nearby, it's going to induce voltage into that wire, and usually it will induce hundreds of volts uh, into that wire, and it took out one of the power supplies. Well, I was able to get that power supply repaired, and the only thing that was wrong with this supply was the switching chip. What is it? 494. Um, what is it on over here? Yep, it's Texas Instruments 494 um, switching chip. And the first thing that was obvious on this, well, let me tell you how I was able to fix this one. Um, there's a gentleman. I'll put a link to his video down below, who gave a description as to how these work. I mean, typically, whenever you have something like this, it's like, okay, is the fuse good? Is the inrush current, thermal resistor good? Is the bridge rectifier good? Okay, all of that stuff is okay. I didn't see any, damage that was visible. Uh, Check the big power switching transistors. Are they good? And those did not appear to be shorted or open. They appeared to be okay. I did heat this board up and remove those just to, I didn't have a reference of what that should look like in the circuit. And so you'll see there's a little bit of burn right here where I added some heat on the back side to help remove those things. You have bridge rectifier diodes here. Are they good? And they were good. And at that point, I'm like, okay, all the things you think would be bad are okay. Now we're getting into the magic of switch, a switching power supply. And it's kind of interesting the way that these things power up is this little transformer right here. Okay, this transformer, these little transistors that are right here, all form a little self-oscillating switching circuit. So whenever you power it up, enough power gets to this transformer to cause it to start self-oscillating. And that transformer will provide enough power to get the switching chip started. And once that starts, then the power supply boots itself up. It's how it bootstraps. Um, and so I checked the output, on this guy. Um, it has a little resistor uh, that then on the schematic it says that's VCC, and I checked, and it's should have been about 8 volts or more. No, nope. it was 1.5 volts. It's like great. And that guy's video, what he did is he pulled the chip out, put a socket in, and I did the same. And with that, I was able to remove the chip, power it on, and I could see that it was self-oscillating and an appropriate amount of voltage was visible on the output there. Whenever I put the chip in, then it would all fall apart and the voltage would drop down real far. So what I did is I hopped on Amazon, because Amazon's kind of my go-to at this point, because I can get things in 2 days, and I bought 20 of these chips for like $8, shipping included, and bought those bad boys. Um, Popped this guy in, all good. Came back up, everything's great. So woohoo! I'm like, I'm good. I got one of these fixed, and these are magic to me. Okay, then I wanted to inspect one from a lightning strike that occurred last year, and so it's another supply, almost identical. Board has a couple of different screw holes, but the components are the same. The component descriptions have the same numbers and everything. It's the same schematic for this guy. And so I'm like, all right, I will go ahead and pull out the chip. And I'll pop it in this other one and see how it does. Well, what I found is that one of the legs that supplies signaling to cause these guys to go ahead and start switching like they're supposed to was just on. It wasn't switching like it was supposed to. Okay, all right, that's bad. So pull that out, put a new chip in, power it up, nothing. Only had 1.5 volts on the output right there. Even during self-oscillation, 1.5 volts, no power light as well. And so I started playing one of these things is not like the other. I'm like, okay, well, I know that it's going to be in the self-oscillation circuit. And so over here, this is the transformer drive. So you have this transformer up here, and here's the driver that gets that bad boy going. Well, everything looked good. These resistors look good. Those resistors look good. The transistors look good from what I could tell. The Zener diodes looked okay. There was I couldn't tell if there was a short across the capacitor or not, because it looked like a short. And then I checked across these two diodes right here. These are 1N4148 diodes, and they appear to be shorted. And so I pulled those guys out, and whenever I pulled them out of the board, and here they are. They measured bad. I'm like, man, all right, those little glass diodes like that, I've seen those somewhere before. Like, I think I may have some. And so back, I don't know, 10 years ago, when Radio Shack was liquidating all of their assets, I bought a big, they came in like, it looked like fishing lure cases that had all these different components in it. And sure enough, they had 1N4148s in there. I'm like, all right. Pop those bad boys in there, put in a new chip, boom, came right up, no problem. So this guy's working. So now I have this guy, and it is the same type of power supply. And let's see what we can do to get working on him. It's a model 36012. There's supposed to be 30 amp supplies. You get them from Amazon. They come in boxes like these. Super generic. They cost about $20. Yeah, all made in China. Apparently these power supplies were the basis for them was designed by a ham radio operator in Mexico, and he shared it with ARRL, who published it in QST magazine. And this self-oscillation design was something that he kind of come up with, I guess. That's the first known um, example of it that a lot of people have seen. And man, those Chinese dudes just went at it and built these things. So let's go ahead. Let's take this guy right here. Go ahead. I've already got a power cable on him. Let's see here. There we go. We've got some voltage there. Let's see here. Let me swap this around. There we go. And I'm going to plug it in the wall and see what we got. All right. Looks like we have some voltage. I did notice that the pixels appeared to be working very dimly and only the red LEDs were lighting up, but they were animating, so there had to be some voltage there. All right, we got 9 volts. I got that reversed. All right, 9 volts. Well, that's a pretty good indication that it's self-oscillating. Hopefully it's not going to be a big honking switching transistor or diode that tows. Crossing my fingers on that. So yeah, let me go ahead and disassemble this thing, and we'll start some real troubleshooting with it. Okay, well, we've got it disassembled here. And so, word of warning. This can kill you. There's over 300 volts that's inside this guy. The 120 gets rectified, and on these caps right here, man, you got like 300 volts on that deal. So, you got to be careful about what you're doing here. Oh, I was not careful. Let's fix that. Okay, so be careful about what you're doing here. That could have been bad. Sad thing is, it's not the first time I've done this. All right, so we have an LED. Go ahead and set this guy here. Hopefully, nope. There we go. All right, you guys can see that. All right, 9 volts there. We're gonna look on the output here. Oh, not good. Oh, not good at all. There's hardly any voltage on the output of that transformer. So let's check. Wow, I'm hearing some buzzing too. 1, 2, let's see. This is going to be 9, 10, 11, 12. Pin 12 is the input to that. Only half a volt. No good. There's not enough power. There's not enough voltage to make that switching chip turn on. So it's not operating in switching mode. it's obviously got some problems there. So let me go ahead and tear this thing down further, and we'll get into it some more. Okay, guys, so we have it released from its prison, and first thing we're going to do is take out that IC and see what those values, see how it behaves once it's just self-oscillating without a switching IC in there. Hey, there we go. And it has been released from its PC board prison. All right, so first thing I'm going to do is we'll go ahead and just put a little mark on this guy so we know that guy is suspect. And the next thing we're going to do is we're going to go ahead and solder in a replacement or a socket. All right. Well, that is done. And looks, oh, nope, there's a problem. Don't like that. Don't like that at all. Don't want anything that even resembles a cold solder joint. So let's see here. All right, that looks pretty good. All right. So, no socket. Let's check the wires. Plug it in. And yeah, looking kind of dim on the output there. Let's slide this down just a little bit. And let's check our voltage. All right. 3.5 volts. Okay. And then let's check voltage on pin number 12, 9, 10, 9, 10, 11, and 12. 7 volts. There we go. That's what we wanted to see. All right. So now we will unplug it. And I have here a whole bag of these guys that I got off Amazon, shipped for free in 2 days to my house. All right. Looks like we have all of the pins in there. I'm gonna get away from it. Let's see what happens. Hey, we got a pretty bright power light there. 12.31 volts. It's fixed. Done. So I've had 2 lightning strikes, and well, technically I've had 3, but I've had 2 lightning strikes that have killed power supplies. Every one of those caused that chip to fail. One of them caused the diodes that are a part of the switching circuit to to fail, so it couldn't self start. But man, that's worth the time of understanding how they work, and it wasn't that difficult to fix any of these. I'm very pleased with it. I will put this schematic right here. I'll put it down below in the links in the description. There's another gentleman that actually had this specific schematic, which matches my power supply perfectly, um, out there. And there's another gentleman that has a video describing how the self-start works. I will put links to that as well. But yeah, man, I'm rather pleased that we were able to repair all three of these supplies. I mean, that's $60-$70 worth of power supplies that cost me $8 to repair plus my time, which is I enjoy doing this stuff. This is fun for me, uh, so it's not bad. Anyways, guys, take care and be safe out there, and we'll talk to you soon.